Hi team, today we're going to talk about IKEv version 2 or IPsec VPN. Okay, so basically IPsec VPN is like a way for like connecting, like you have different types of VPNs. We have site-to-site VPN, and we have remote access VPN. Okay, site-to-site VPN is, let's say you have two different branches. Okay, you want to connect those two branches together. So this is what we'll do. We'll use IPsec VPN. Okay, we'll use IKEv version 2, which is the modern configuration setup. Yeah, and we'll do a route-based VPN. And there is also something called SSL VPN. Okay, and for remote access VPN, we have to, this is when you want to, for example, you just want to allow one single PC or host to access your internal network from outside of the internet. Okay, so this is, you can use like tools like AnyConnect, or there are many tools that used to access internal network from outside. This is called remote access VPN. This is for a single host. This is for an entire network. Okay, and there is more we have on. So this is what we need to know about IPsec. Okay, IPsec is basically a suite of framework. Okay, that contains like protocols like this. SA is security association. Okay, it is an agreement on how to do crypto. Okay, basically just understand what SA is. AH is an encryption. AH is a protocol. Okay, it's no longer used, so you can ignore it. It's no longer used because it doesn't give you encryption. Okay, we have ESP. ESP is a replacement of AH. Okay, because it provides encapsulation and encryption, and it's like a header that's going to be on top of your packet. This is ESP. It's very important. The header done on top of the header. It operates in a L4, layer 4. Okay, and ESP has security parameter index, like port number. It's so tunnel mode. There are two things you need to know also here. We have two types of connections. Tunnel mode protects the the original packet, entire packet. Transport mode used for two host device only protects the payload. Okay, but mostly we will be using this one right now. In most cases, you'll be using the tunnel mode. And there is one thing that we need to know about. NAT also affects the VPN. NAT, because NAT, it needs port, right? If you remember the course, we talked about PAT, right? Port address translation. When how we translate private IP to, or internal private IP to the public IP. We just map them using the port, right? Different ports. But the problem with NAT is NAT doesn't actually. IPsec VPN doesn't like NAT. VPN doesn't work well with NAT. Okay, because NAT, it needs to modify the port, and the problem with ESP has no port field. Okay, there is no way to port field. There is a workaround like IKE uses UDP 500, but phase 2 doesn't. Okay, so and yeah, we'll go back to that, but first let's see the difference here. IPsec works in layer 3, SSL TLS works in layer 7. Requires NAT. IPsec requires NAT. NAT reversal is a way to add ports on the packet. It uses UDP for 500. Let's see more on NAT reversal. It's a way how we can set up VPN even with NAT. And it's one of the most common issues that most people face on VPN. It's due to NAT reversal. So knowing it is useful. This is with NAT reversal, a set of techniques allowing direct communication between devices on a private network behind NAT and the internet, overcoming NAT limitation. Like yeah, here NAT UDP is a key for VPN to work across NATs. Okay, more on this. 1 second, I will show you. Yeah, also known as UDP encapsulation. It's a UDP encapsulation. Okay, it's crucial for IPv6 to function through network and the administrative translators because it traps IPsec packets like ESP. Okay, remember, inside UDP packets. Okay, allowing NAT devices to translate the outer header while keeping the inner IPsec intact, resolving conflict with how NAT process protocol like ESP. Without NAT, IPsec direct use of protocol like ESP often break when passing through NAT, causing connection failure. But UDP encapsulation makes IPsec traffic look like standard UDP traffic. Okay, why not break traditional IPsec? NAT modifies the source IP address and port. Told you, right? So in the IP header, okay, which invalidates IPsec cryptographic check, leading to packet drop. Okay, IPsec does not have a protocol number. It doesn't have ESP. It doesn't have it doesn't have any port number. Okay, so especially with part, yeah. So the solution is for IPsec VPN to work, we use a UDP wrapper. We encapsulate the ESP packet. On top of it, we put a UDP wrapper. Puts the IPsec packet ESP inside the UDP packet. The NAT device translates the outer UDP header, okay, using UDP port 4500, treating the IPsec packet as a normal UDP traffic. It doesn't touch the IPsec packet. It only modifies the outer UDP layer. The IPsec information remains untouched. During the initial negotiation, phase 1 endpoint detects the presence of NAT. Right? Switches to using UDP encapsulation on port 450, which controls traffic, uses port 500. Channels between devices are not addressable. So this is the common. This is very important. We have to understand, so that because this is one of the most common issues. I can show you how the packet ESP packet or ESP header and IPsec. Yeah, so this is an ESP. This is the original IP packet, right? IP header, TCP header, data. Okay, so it will add ESP header here. Okay, then ESP trailer, ESP trailer, and not or UDP. Yeah, this one will show us
NAT T, short for.
Yeah, we can see it here actually. Okay, before applying ESP here. Okay, before applying ESP UDP encapsulation packet, yeah, this is how it was, right? After applying ESP and UDP encapsulation, this is what it becomes. It's the outer IP header, okay, and UDP header, not T, port 4500, this one. Okay, then we have the ESP header here, IP header, TCP UDP header, data, ESP trailers. So the idea is it just added here, detects if both ends supports NAT T, detects NAT T to NAT device along with transmission path. So this is NAT T. And so what else we have now? We can, yeah, the next thing that we need to know is that we have two phases, like IKEv version 1 and version 2. Okay, we're only going to talk about version 2 because it's the latest and most modern way of doing it. Okay, first phase we have the IKEv version 2 proposal here. Let's have a look at IKEv version 2. IKEv version 2. IKEv version 2. So modern VPN talent using within IPsec protocol suite. It is established managed secure connection between devices. Yeah. So what we need to know about IKEv version 2 is that it's faster than version 1. Okay. It's also it supports dynamic routing protocols. Version 1 only supports static routing. It's more lenient on NAT issues. NAT T. Okay, and has less commands to type to configure it. Okay, so the first step we need to do is we have to configure the IKEv version 2 proposal and policy. Okay, this is the one. We'll start the configuration now. So let's restart this one. Reload, and reload. So the thing about this VPN is that usually you will see that different companies will use different vendors to configure VPNs, different devices. Like VPN can be configured in FortiGate firewall, it can be configured in Palo Alto firewall, and it doesn't have to be configured on a router. So the main concept that we need to know is the idea of the main. We have to understand is the concept. The commands are not really well, because you might not you might not if you might not use this commands in the real world. You just have to focus on understanding the concept, because there is actually the commands is very long for this configuration. Okay, so we are going to start our configuration. We will assume that this R3 is actually an internet. Okay. Okay, I will assume that this is an internet. So our task is that to make sure that R1 can communicate with R2 via VPN. Okay, we'll configure it that way. So let's start with R1 and F0 over 0 IP add 192.168.1.1 255.255.255.0 no shutdown, and it's F0 over F0 over F1 over 0 IP add 1.1.1.1 255.255.255 wait 255.255.0 no shut, and let's configure this one as well. R3 config T int F0 over 0 dot 2 255.255.255.0 no shut, int F1 over 0 2.2.2.2 255.255.255.0 no shut, and let's configure this one as well. R2 config T and F0 over 0 IP add 192.168.2.1 255.255.255.0 no shut, F1 over 0 IP address 2.2.2.1 255.255.255.0, and we are done here. Now let's start with the actual configuration. In R1 we are supposed to configure the IP route, so it will have access to the exit IP route. We're going to set the default gateway to 1.1.1.2. Yeah, I think this is the configuration. Yes, .2. And in R2 we are going to do the same thing. R2 exit IP address, IP route 1.1.1 0.0.0.0.0 0.0.0.0. We'll go to 1.2.2.2.1. Actually, it's going to be 2. Yeah, 1. And this is supposed to be the it should be the 2 actually. Yeah, so let's see, to show IP routes. Yeah, so this is the default gateway. We can test by pinging from R2 to, let's do ping. No. Okay, I'm supposed to actually do an R3 as well, the routing, because I'm supposed to configure the IP route. I'm telling it anything that comes to this network, send it to this one, right? Anything that comes from here, send it to here. So let's just check here. Ping. So ping 192.168. Okay, I can't even show IP, at least it's 1211, so I think the IP configuration in R1 is not actually correct. I should be able to ping the R1. Let's go back and see the IP configuration of R1. Do show IP interface brief. The IP configuration of R1 is correct, but for some reason it's not. I can't ping from the PC1. Hosts are reachable. Let's actually make sure that the ports are correct. It's correct. So there must be an issue with the. Stop this one and start again. Show IP. IP 192.168. /24 68. Ping 192.168. Good. Okay, so right now this is not actually pinging the gateway as well. So let's just so let's configure the let's start the configuration. Yeah, let's start the configuration. Crypto IKEv2 proposal. It's the first step. IKEv2. Remember the name because the name is important. I'm gonna keep it capital so that I can proposal. Okay. So once we do this, it asks us IKEv2 proposal must have at least encryption algorithm and an integrity algorithm and a DH group configured. Okay, so now we will configure the encryption. We will use AES CBC and 256. And the next step is the hashing, which is the integrity action. What integrity is hash? You can just mention PRF here and SHA-256. Yeah, I guess this router doesn't support that, so let's just make it integrity SHA-256 and then group 14. Let's see if we have 19 because the best is 19 actually, but you can use 14 if you want. 19 is better. And then let's define the policy. Crypto policy. So crypto IKEv2 policy. IKEv2 policy. Policy must have at least one complete proposal attached. So let's attach the proposal. We have a proposal upright. We'll just make it here IKEv2 proposal. So this is the first step, phase 1. We define the proposal and so let's understand what we did here. Sets authenticated, so yeah, this stuff must match exactly on both. This is the negotiation parameters. It has to match on both the routers. Okay, before we move on, let's just do show history. Okay, and it's going to give me the commands here, right? All I have to do is actually just Control C and just paste it in R2. Yeah, so we have done that. So this is the first step. The next step is the VPN keyrings. Let's go to R1 here. Crypto config T crypto IKEv version 1 version 2 keyring VPN keyring okay, peer will be R2. Okay, and the address, we'll define the address of R2, which will be 192. What will be the address of R2? It will be 192.168. Match the VPN IP. No, actually the address will be 2.2.1 because this is the one IP, right? And pre-share key. Basically, keyring is like a way to share the pre-share keys, the keys. Pre-share key. I will just name it Cisco 123 for lab environment. And we are done here. And I will do the same on I'll create again crypto IKEv version 2 profile IKEv version 2 profile. I'm going to link both. So it's asking the local and remote authentication method and match identity and match certificate. So let's match the identity. Let's start with match identity. Identity, remote address, which is 2.2.2.1. 255.255.255/32, and then identity, the local address, which is 1.1.1.1, authentication, remote pre-share. Yeah, and authentication local pre-share. Okay, and then I'm going to link the keyring here. Keyring local VPN keyring. So that's it. Exit. Now do show history. So before we do we repeat this, let's we can copy this one. We can copy this one. Let's see, and put it here. Notion. Create a new Notion. Paste it here, and here is going to be the opposite. 2, 2, 2. It will be 1 here, and here it will be 1, 1, 1, 1. This is for the router 2. But before pasting this command, I have to put the keyring on R2 because I didn't do that. I just did the proposal. So crypto IKEv version 2 keyring VPN keyring peer R2 address 192.168. No, actually the address of the other one would be 1.1.1, right? And then the pre-shared Cisco 123. So okay, now I'm just going to copy this one and paste it here. Yeah, so that's about it. And there's one more configuration here, transform set. Yeah, this what we did now is just handle authentication and peer identification. It's used to make R1 and R2 trust each other. Yeah. Now this is the transform set. It's one more configuration. Config T and crypto IPsec. This is phase 2 actually. Now we just completed phase 1. Okay. Now we will start with phase 2. Okay, now the security association is complete. We finished phase 1, now we'll start with phase 2. Phase 2 is basically the transform. Make the transform set and link it with the profile, the encryption, and also define the tunnel. Let's create the transform set. I would call it TSP. ESP GCM. Here we have GCM, so we'll use GCM. And let's make it 256. No, but let's use GCM, no problem. 256. Then the mode has to be tunnel. Exit. Now we will create crypto. Create a profile for the IPsec. Set transform set. I'm going to set the transform set STS, the one that we created. Set IKEv2 profile IKE. Crypto IPsec transform set TS defines phase 2 encryption, uses ESP. Yeah, okay, so this one defines how data is encrypted and protected after the tunnel is up. Okay, so this one links phase 2 to phase 1 negotiation. Okay, yeah, that's what we did here. We just linked the phase 2 with phase 1 negotiation. Okay, now this is the last part. Okay, before we move on, just do show history. I'm just going to copy this one and I'm going to paste it in R2. So this is done, and the next step will be the tunnels. Configuration. So the first thing I will do is configure tunnel in R1 and tunnel 0. The IP address of the tunnel will be this is the, you can use a different subnet IP like root 1 255 to 255 to 255. You can keep it like it is there. 255 to 255 to 255 to 255 0. So then the tunnel source will be gigabit over 1. So let's check what's our tunnel source. F1 0, F1 over 0. Right. Tunnel destination will be 2.2.2.1. Tunnel mode will be IPsec IPv4. So now let's exit and configure the IP route. IP route. IP route. IP route. To go to this network, we have to go through this tunnel, right? Basically, that's what we're saying. Yani we're saying to reach this network, you have to go through this tunnel, okay, 2.0. So this is the exact command that we need to write in R1. IP route 192.168.2.0 255.255.255.0 tunnel 0. Done. Now let's just do show history. Let's go ahead and just copy this one and Control C. Go to Notion, paste it here. So what we need exactly is to change the IP, make it 2 instead of 1, and the port, let's check to confirm the port of R2, it is F10. So it's same, the source, destination will be 1.1.1, and the IP route will be .1 network actually. Put this in R2. Let's put this in R2, right? Now let's see what happens. Okay, perfect. First, let's check the IP address. Juche IP int brief. Make sure the IP is actually correctly set. Yeah, the tunnel 0 is correct, but it's down for some reason. F10 is 1.1. F00 is okay. This is fine. Let's do here to show IP and brief. Yeah. So yeah, it's 2.1 and 2. Yeah, this is also correct. The face is down for no reason. So creates that one. Yeah, the only thing is the protocol is down. Okay, let's try this configuration. Show crypto IKEv version 2. You show crypto.